Hi students, so in this video I'm going to show you how to solve a problem in which in a water treatment plant fresh water with density 1000 kg per meter cube flows at 3 meters per second through a horizontal section of pipe 60 mm in diameter. The section of the pipe gradually tapers to a diameter of 90 millimeters. You have to calculate the volumetric flow rate in the pipe, calculate the mass flow rate in the pipe, and calculate the velocity in the section of pipe where the diameter is 90 millimeters. So whenever you are given a problem like this, it's a very good practice to first make a rough diagram of what the question is asked. So here you have a horizontal, a pipe which is tapering, which is it gradually tapers from 60 millimeters to 90 millimeters. So you write your given data, so that's 60 millimeters inside and 90 millimeters at the out. Always whenever you solve a problem like this, you have to have your dimensions in meters. So 60 millimeters will be equal to 0.060 meters. All you do is you multiply this with 10 to the power minus 3 to convert it to meters. And I have done the same thing to the second dimension. I multiplied it with 10 to the power minus 3. Basically, when you multiply it with 10 to the power minus 3, you're moving the decimal place, which is at the extreme left here, 3 places to the left. So 1, 2 and 3, and hence I get 0.090. 1, 2, 3 places. I have done for the outside diameter and the inside diameter. Now you have to calculate the volumetric flow rate. Volumetric flow rate is given with a formula area in times the velocity of the fluid going in. Now this formula here is not given in your formula sheet. So make a note of this formula and you will have to memorize this. Area in, or the, because this is a circular pipe, the cross section is basically a circle, sort of like a circle. So is this, it's circular, it's like a pipe which is a circle. Area is pi divided by 4 diameter squared times the velocity squared. Now because it is at when you're going in, that is why I have given it a suffix of in and in. Pi divide, the value of pi is 3.142 divided by 4. What I want you to do is write down this problem as I talk you through it. Pi is 3.142 divided by 4, and if you are going slow, just pause the video every time you want to make a note, times 0.060, which is the inside of the pipe at this point here, squared times the velocity with which the liquid is flowing in, which is 3 meters per second, which is given in the problem. We have made a note of it. So when you multiply this, get your calculator out again, 3.142 times 0.06 squared times 3 in the numerator, and in the denominator we got a 4. We get 8.48 into 10 to the power minus 3, which I have written here. Now 10 to the power minus 3 simply means the decimal point has to move 3 places to the left to get it in your meter cube per second. Why I have done this step? It is simply to get rid of this 10 to the power minus 3. I have simply multiplied it in the number, and I have moved the decimal point from 1, 2 and 3 places to the left. Next part is we got to calculate the mass flow rate in the pipe. The mass flow rate is given by m dot, and it is equal to density times the volumetric flow rate, which we calculated in the previous part. This formula here is again not there in your formula sheet, so you will have to memorize it. Okay, it's very simple. Mass equals to density times volume. We have used the same formula, but here you're using rates. So that's mass flow rate and that's volumetric flow rate. Density we are given as 1000 kg per meter cubed, so that goes here, times the volumetric flow rate which we have calculated in the previous part. When you multiply 1000 times 0.00848, we get 8.48, and the units of mass flow rate are kg per second. In the third part, we calculate the velocity in the section of pipe where the diameter is 90 millimeters. It is basically the outer section. So that is part C. And how do you calculate the V out? For this, you got a formula. Area in times the velocity of the liquid which is going in, as 3.5 meters per second, will be equal to area out. So area over here times the velocity of the liquid going out. This formula is there in your formula sheet. On the very last page, under fluid principles, you got continuity of volumetric flow. Area 1 times volume 1, oh sorry, not volume, velocity 1 will be equal to area 2 times velocity at the outer section or the second section. So I have used the formula. Area is pi divided by 4 diameter squared times 3, which is the times pi divided by 4 diameter squared times the velocity in, which is 3 meters per second, which is going to be equal to pi divided by 4 times diameter of outer squared times the velocity out squared. Now we have, since we have pi divided by 4, pi is a number, 4 is a number, it's a constant, and it is the same on both the sides of my equal to sign, and that is why I can cancel it out. Basically, if I get this entire number on the other side, it gets divided by, and because it's the same in the numerator and the denominator, they simply cancel out. So I am left with diameter in squared times 3, which will be equal to diameter outer squared times velocity out. Now my V out is my subject, or this is what I want to find out, the velocity at the velocity of the pipe where the diameter is 90 millimeters. So that's what I want to find. That is going to be equal to, I'm going to rearrange this equation now, 0.060 squared times 3, I'm going to write it as it is. All of this entire term, because it is multiplied by, when it goes on the other side of the equal to, it goes as divide. That is why I have 0.060 squared times 3 over 0.090 squared. That is going to be equal to my velocity out. And when I enter this in my calculator, again I have my divided by out, 0.06 squared times 3, and in the bottom I have 0.09 squared. That is going to be equal to 4 over 3 or 1.3333 recurring. I only write my answer to 2 decimal places. So that's going to be 1.33 meters per second. That's going to be my velocity out. Now whenever you solve a problem, it is a very good practice to highlight your answer so that the examiner knows where to look for your answer. That way you will not lose marks. And that's my C, velocity out. So now what I want you to do is, now that I have explained the problem to you, I want you to stop this video, take a note of this problem and try to solve it without looking at the video. Good luck.